So we finally worked ourselves up to a point where we can talk about the really number crunching of this lab and what do we expect you to do for the lab. So we left off with this explanation of Beer's law, and we said that Beer's law is A equals EBC. And A is the absorbance that's printed off on your receipt ticket from the instrument. E is the molar absorptivity. B is the path length of the cuvette, and C is the concentration of the sample that you made that was ran. Okay, so what do I do with the data from this point? Well, what's happened up to here is that you have probably have gotten an absorbance value. And that absorbance value should now be, of course, in your spreadsheet. So for my 3 microliter sample, I have an absorbance at 260 of 0.414. So I'm going to come over to the side and I'm just going to put my number into that equation. So 0.414. So 414 is the absorbance from the machine. That's equal to the molar absorptivity. Now I'm going to pretend like I don't know the molar absorptivity for this particular lab. That is the number that we're after. And I'm going to multiply that by B, which is the path length of the cuvette. And the path length of the cuvette is always 1 centimeter. That's what you use to run the samples in. So this is going to be multiplied by a 1, and then that's going to be multiplied by the concentration of, in this case, the 3 microliter benzene. So that's the sample that we are working on here. We're only going to do one, and I'm going to let you do the rest of them yourself, but this is the 3 microliter benzene sample. So the concentration of the 3 microliter sample, it was right there. Right? I had Excel to do that calculation for me. That's the number that we use the density and the formula weight for. So 0.00338. So in the molarity, 0.00338. So the only thing that I have to do here is solve for molar absorptivity. That is the number that we are after. So I'm going to take 0.414 and I'm going to divide it by 0.00338, and that gives me the molar absorptivity for that particular sample. Now, anytime I multiply a number by 1, I get that number, right? So that's why I didn't bother with this multiply by 1 nonsense, because I can just really almost imagine that it's not even there. The tricky part is that if this was a problem that didn't use a 1 centimeter cuvette, then you've got to put in the real dimensions into this spot. So this is based in per centimeter. Molar absorptivity wise, so this has got to be centimeter at that step. So whether this is a 2 centimeter or whether this is a 10 centimeter vessel, you've got to put that number in there. Most of the time it's going to be 1, but don't let me trick you up. So once I do that, I'm going to let Excel do that calculation for me as well. I'm going to say, okay, take my absorbance, 0.414, and then I want to divide it by the concentration, which is 0.00338. And that's the molar absorptivity that I got here in that column, which is 123. I do that for every lambda all the way down. So once you put in the correct formula and calculation, you copy and drag it all the way down to the bottom, and it will do those calculations for you all over. Then I do the same thing for the 5 microliter column, right? But instead of using the 0.00338, I'll use the 0.00563, because that's the molarity for the 5 microliter. Instead of using the 0.414, I'm going to use the 0.637, because that's the absorbance for the 5 microliter. So over here to the side, if I need to do that, I'll do it. We'll put 0.637, that is the absorbance, equals the molarity, molar absorptivity, sorry, times 1, because it was a 1 centimeter cuvette, times the concentration of the 5 microliter benzene, which is 0.00563. That's what I got. You might have got something different, but 0.00563 is what I've gotten here. Okay, so I do the setup the same way. I take my absorbance and I divide it by, in this case, it's simply the molarity of the solution that I made, and this gives me my molar absorptivity. Okay, so now what do we do with these molar absorptivity numbers? Well, these molar absorptivity numbers are not going to match the book. Okay, they just simply won't. And it's okay, we don't expect them to. They will not match the reference. It's up to you to really explain why that molar absorptivity doesn't perfectly match. And you do that in the conclusion of the laboratory. So why don't they match? Give me a couple of reasons. What could have happened to throw these numbers off? I think that you could easily come up with a couple of answers at least. So what you're seeing in this column is a percent error calculation. So that means I should have gotten 149 for my molar absorptivity. My 3 microliter sample gave me 123. So how far off am I? That is the percent error calculation. So 149 is what I should have gotten from the book value. I didn't get 149. Instead, I got 123 for my 3 microliter sample. So I take these two numbers, and of course you do a percent error. So you subtract them, and then you're going to divide by the accepted value of 149, and you multiply by 100 to get percent error. And that is where this last column of 17.7 comes from. So that is the calculation that goes on. I am 17% off from the true molar absorptivity. Now, notice here with my 5 microliter, even though this was a different concentration, well, that's okay. It gave me a different absorbance because of that. And these ratios should be very close together. So I got 123 with the 3 mics. The 5 microliter, I ended up getting 113. So 149 is still the book value here. My 5 microliter molar absorptivity gave me 113. And I do the same thing that I've done before with percent error. I'll take 149 minus 113, divide it by 149, times by 100, and that gives me percent error. So all the way down, I'm going to see a percent error for the 5 microliter, and I'm going to see a percent error for the 3 microliter. A part of your conclusion, you should state which is better. Is your lower concentration better, or is your higher concentration better for each sample? And maybe explain why you're seeing that. So if you take a look at the data on this spreadsheet, you're seeing that all of my 3 microliters are fairly lower compared to the 5 microliter sample. Yours might not be the exact same thing. Yours might show something completely opposite. But it's up to you to explain why that is happening. So here, my 5 microliter is giving me a bigger error overall than my 3 microliter sample. And in my conclusion, I want to state that. My 5 microliter gave me worse error, and this is maybe 1 or 2 of the reasons that I'm seeing a larger error associated with the higher concentration value. Again, yours might not match the same way, yours might be completely flipped, or yours might be something similar. But that is what we are after for the lab calculations concerning UV-VIS intro. That is it. You need to put in perspective, you're calculating molar absorptivity all the way through the spreadsheet. The spreadsheet has to do all of the calculations for you. Do not do any of these by hand and put them in the book and say, I did them by hand, they're in the book, now you take a look at them. The power of Excel will do it for you, and you've got to get used to Excel, and that is what we're doing here. So that is the spreadsheet, that is what we're after, and you'll do that for the high and the low for all 4 samples, MIBK, benzyl alcohol, alcohol and acetone as well. So good luck with the calculations. If you've got questions, you know how to get in contact with us. You know how to get a hold of us. Do not copy and paste spreadsheets from person to person. Do your own work. It doesn't even have to look like this. I don't care what it looks like. As long as I can make sense of your data and your Excel spreadsheet itself, that is all that we're asking. So do your own work, do your own calculations, make sure that you understand what you're doing in the lab before you do the next one. As far as the calculations go, I could have done all these labs at one time and cranked out data and attached receipt tickets to my lab book and not done one calculation in the very end. So now I can actually go back and take a look at these calculations and maybe they'll make a little more sense. So good luck with them. If you've got questions, you know where we are. And that's the UV-VIS intro. It's molar absorptivity, people. That's all that you've got to do.